Hello everyone. In this tutorial we want to show you how you can model the one-way slab in CYPECAD. So we received different comments from our subscribers to show them how to model the one-way slab in CYPECAD. So here I prepared two slab models. If I go to render view, so this is actually two slabs with the columns and beams. And for one of them, so we want to assign the one-way slab, and for another one as two-way slab. So here also we select the geometry in such a way that to monitor the, or let's say to achieve the one-way slab concept. So here is 7 meter and here is 3 meter. And similarly for the two-way slab that we are gonna model it, here also we have the 7 and 3 meter respectively as well. Okay, so usually, or let's say in general, once you want to design or model the one-way slab, so you need to go to the slab panel manager, and here you have the enter panel. Okay, so click on this enter panel and you need to go to joist floor slab. So this kind of slab that you have here, which is joist floor slab, so they are representative as one-way slab. Okay, so you can use any of them. So here you have the reinforced joist floor slab, you have the pressurized joist floor slab, you have the in situ joist floor slab, and also you have the steel joist floor slab. Okay, so this kind of slabs actually can be modeled or can be used to model the one-way slab. If you go to cype website, so here you can see actually for the one-way slab, so here you have the concrete joist, okay, reinforced precast, precast pre-stressed, reinforced in situ, and post tension in situ, okay, and also joist, steel joist, and also timber joist floor slab. Okay, so all of them, if you go back here, so you have the same thing. So here this 6 type of slab can be used for modeling one-way slab. So let's take a look at this. So for example, here I want to use the reinforced joist floor slab, and from here I can create my own joist floor slab. So here I have it. So I name it as for example, one-way slab. Okay, and then here you have the geometry. So just you need to key in the value. So the rib spacing, maybe this one is not that matter, but the thing is that actually if you want to consider the weight of the slab, and also the weight of a slab should be distributed to the surrounding beam, especially the long beams. Okay, so you may need to take care about this parameters to come up actually with the total weight of the slab. Okay, and here also you have different type of forms like concrete, ceramic, polystyrene, and also any generic let's say type of material. Okay, and then here you can enter the surface weight of the slab. Okay, so assume that here, so you can add the surface weight. Okay, so let me go back to concrete, so you can set it up with yourself, and then so I will accept it. So I did nothing else, and then accept. And for this one I'm going to model it as one-way slab. Just click here, and then so for this one either you can select this or select this. Let me select this beam. Okay, and then as you can see you have the direction of the ribs. Okay, if I go back here, and once again if I go to let's say here, let me just name it with any reference. Okay, and then accept. If I click here, and here the direction of the rib should be like this, which means here this beam and this beam will take the loads. Okay, if you just go to the change layout, okay, so here you can say parallel to a beam, accept, and then so I can select this one, and then you can change it. Okay, so later we will come back here and we will see the effect of rib directions. But for this one, we are going to have the flat slab, which is a two-way slab. Okay, so simply I will go to enter panel, and here I have the flat slab parallel to a beam. Accept, accept, accept. Okay, so now we have the two-way slab and we have the one-way slab. Let's look at the results. So this in one-way slab, this beam and this beam should take the loads, the most of the, or let's say most percentage of the loads here. Maybe you know this beam and this beam, so they have amount of moment due to their own weight. Okay, so let me go to analyze, and then here I will select the project analysis except foundation. Okay, and then close this. So now we can look at the results. If I go to the result, let me, from here I can just go to sorry, never mind. So I can go to forces in beams. Okay, so from here I will select, you can go for envelope, you can go for load case, or you can go for combination. Okay, so let me go to for example, here you have the dead load. Okay, so for the dead load, already I applied the 3 kPa or 3 kilonewton per meter square to this floor and also to this floor. And for live load, I applied the 2 kilonewton per meter square for both slabs as well. Okay, so if you want to look at the dead load, so here I will accept, and then here I can look at this beam reaction. Okay, so here as you can see, you have the maximum moment under dead load as 21 kilonewton meter, and here also you have the around minus 15 or minus 16. Okay, and if I look at this beam, so here you have the 18, and here you have the minus 13. So let's look at this beam here. Okay, if I click on this, you see here, so almost everything is 0. Okay, and if we look at here, so here you have actually now the load. Okay, so here for the moment you have the about 4 kilonewton meter, and for shear also you have the minus 4.4. Okay, so you see that how the loads are distributed between these two beams in this one-way slab. Okay, so here again, if you look at this, okay, so here you can see that it is about 21, and here is about the 6, and if you look at this one, is almost 0. Let's look at the envelope. Okay, so let's go accept, and again here if I click on this, so here you can see that the envelope moment is about 82 kilonewton meter and envelope shear is about minus 60. Let's look at this. Here is about 91. Okay, so as you can see, it takes more loads because you know all the weight of the slab is going to this beam and this beam. Okay, and here you have the minus 28. But if I look at this beam, okay, so here again, since we have the concept of two-way slab, again the moment is about 19.5, and for the shear you have 21. If I go to this beam, okay, you see here you have the about 5.5 for the moment, and for the shear you have the 8.6. As I told you, so it may be, or it can be due to the weight of the beam itself. Okay, so this is the way actually to model the one-way slab. Okay, and once actually you want to model the one-way slab, you can ignore about the slab results here. Just we can take advantage of Joyce Fellowes slab systems to model the one-way slab and check the beam results. Okay, so I hope you enjoy this video, and please let us know if you have any comments, if you have any request to cover for the next tutorials. Please let us know, and we will come back to you soon. Stay tuned with us, subscribe, share, and comment to encourage us for more tutorials. Thank you so much, and have a great day.